Alright, in this video, we are going to look at motion in one dimension. We're going to look at motion in one dimension. Now, we can see here that in this part here, we have position, time, and displacement. I believe you still have maybe a brief idea or little knowledge about position, time, and displacement is something we commonly know. So, we can say that the particle's location is specified by its coordinate, which will be denoted by x or y. Now, they're talking about coordinates. Now, coordinates is trying to explain the position of an object. That's x and y. They use it to represent a position in the x and y plane. That means in the coordinates and geometric plane. That's two-dimensional. As the particle moves, its coordinate changes with the time t. Yes, as the particles move from one point to another, let's say from point A to point B, the coordinate changes with respect to the time. Now, the change in position from x1 to x2 of a particle is the displacement, which is the um, delta x, which is delta x is x2 minus x1. That means the change where the x1 is the initial while the x2 is the final. That means the change with respect to the time t. The change with respect to the time t is the displacement I'm trying to explain. Since they mentioned here that the change in position from x1 to x2 of a particle is the displacement, which is the change in x here, and with that's change in x is equals to x2 minus x1. What I'm trying to explain there. All right, if we move to the next one, we can see average velocity. We can see average velocity and average speed. Now we can be able to differentiate between velocity and speed, where velocity is a vector quantity while speed is a scalar quantity. Now I can see here that the average speed of a particle is defined as the total distance traveled. That means total distance traveled per total time taken. So we define speed as the average speed rather of a particle as the total distance traveled per total time taken when a particle has a displacement of change in, that's delta x, change of time, that's change in delta t here. They now mention that its average velocity from that time interval is, that means the average velocity from that time is, that's the change in this over t, which is x2 minus x1. Well, if you recall that in our previous part here, in our previous part, they mentioned that delta x is equal to x minus x1, which is called the displacement. So we can see that velocity in this case is the displacement over the time interval here. But if you see for average speed here, they are saying that it's defined as the total distance traveled per total time taken. So we can define average speed as distance, total distance over total time taken. But for velocity is the displacement over the time taken, which is t2 minus t1. Yeah. The I mentioned here in general, the value of the average velocity of a moving particle depends on the initial and the final time for which we have found the displacement, which is true. I try to explain this. All right, for move to next part, we have instantaneous velocity and speed. Now, instantaneous velocity or speed is defined as the actual speed or speed attained at any given moment of time. That means the speed attained at any given moment of time. We can answer the question, how fast is the particle moving at a particular time t, by finding the instantaneous velocity. Yes. This is the limit. This is the limiting case of the average velocity when the time interval, that's the time interval, which is the change in t, include the time t and is as small or as small as we can imagine. As small as we can imagine. Instantaneous velocity is trying to explain that you can find the instantaneous velocity at a particular point in time, since they mention the actual velocity or speed attained at any given moment of time. So at a very given moment of time, or at a given moment of time, we can find the instantaneous velocity. We also say here that instantaneous velocity v is equals to the limit that has changed in the displacement of that particle over the time. Yeah, this is what I'm trying to explain there. So here we can see that the instantaneous speed is the absolute value. Absolute value is talking about the magnitude. Instantaneous speed is the absolute value, that's the magnitude of the instantaneous velocity. If we make a plot of x-axis versus t, that means I'm plotting the displacement against the time. Yeah, displacement, which is the x against the time for a moving particle. The instantaneous velocity is the slope of the tangent to the curve at any point. So the slope, that means the point, that's the tangent within that slope, within that curve of that slope, is they are saying that is the instantaneous velocity. That's is the slope of the tangent to the curve at any point. At any point, so instantaneous velocity. Now move to the next slide. We can see here that let's explain acceleration. When the particle velocity changes, then when the particle velocity changes, then we say that the particle undergoes an acceleration. Undergoes an acceleration. So when the particle changes, like when the velocity of that particle changes, we say that the particle undergoes an acceleration. If the particle velocity changes from v1 to v2, where v1 is the initial and v2 is the final, as we all know, during the time interval t1 and to t2, then we define the average acceleration as v2 minus v1 over t2 minus t1. That's the change in velocity with respect to the change in time taken. Now, instantaneous acceleration is given by taking the limit just as we did the previous time in the velocity here, taking the limit of the change in displacement over the time. It's similar here to say that the limit of change in the velocity over the change in the time. Next, if the acceleration A is positive, it means that the velocity is instantaneously increasing, which is true. If the acceleration is positive, means that the velocity is actually increasing. If A is negative, that means if the acceleration is negative, then the v, which is the velocity, instantaneously decreasing. It means that when we have positive acceleration, it means that the velocity is increasing. That means it's accelerating. Then if we have if the acceleration is not negative, that means it's decelerating, or I call it retardating. So the velocity be instantaneously decreasing. At times we may have retardation or deceleration in a problem. The word is used when the sense of acceleration is opposite that of the instantaneous velocity, the motion. Yeah, is what I'm trying to explain and what I said previously. The magnitude of the acceleration is given. Yeah, the magnitude of the acceleration is given with the direction being understood. That means acceleration is a vector quantity. Since they mentioned the magnitude, the magnitude um then the magnitude of the acceleration is given with the direction being understood.